Assalamu alaikum, dear students. Welcome back. In this lesson, we begin chapter 11 by extending coordinate geometry from 2-dimension into 3-dimension. So, in this lecture, we'll be discussing section 11.1. And if you are comfortable with the points like x, y on a plane, then today we'll learn how to locate points in space using coordinates x, y, z. We'll also study two important surfaces in three-dimensional space. Number one, spheres. Number two, cylindrical surfaces. So by the end of this lesson, you will be able to locate points in 3 space, calculate distances between points, written equations, write equations of spheres, recognize and sketch cylindrical surfaces. All right, let's begin. So in 2-dimension, every point is represented by ordered pair xy, where xy is horizontal distance and y is vertical displacement. So to describe location in 3-dimensional space, we need a third coordinate. So that a point can be represented as x, y, z, where x, y is movement along x-axis, y is movement along y-axis, and z, is movement along z-axis. So the three axes are mutually perpendicular, and the axes intersect at a common point called origin, where x, y, z, all the coordinates are 0. And usually we point x-axis towards the reader. On right, we have y-axis and z-axis is pointed upwards. And this is called right-hand rule to represent this 3 space. We can also use left-hand rule to represent 3 space, where y-axis is pointed towards the reader. So let's try to locate the point 1, 2, 3. For this, move 1 unit along x, then move 2 units parallel to y-axis, and finally move 3 units upwards. The resulting location is the point A with the coordinates 1, 2, 3. Let's have a look at another example. Here we are going to locate the point 1, 1, 1. And this is a different representation of the 3 space. So as we just discussed that 3 space consists of 3 perpendicular axes, it also consists of 3 perpendicular planes. This is xy plane, and then we have yz plane, and here we have xz plane. So these are 3 perpendicular planes which are called coordinate planes, and these axes are called coordinate axes. So this is another view of these planes. And these planes divide this space into 8 equal parts. If you stand here in this corner, on your right you have xz plane, on your left you have yz plane, and above xy plane, this is xy plane, above xy plane z is positive and below xy plane z is negative. So on xy plane, every point has z coordinates equal to 0. So equation of xy plane would be z is equal to 0. Equation of xz plane would be y is equal to 0. And equation of yz plane would be x is equal to 0. And these equal parts, 8 equal parts, are called octants. And if you are interested in signs of the variables in each octant, so this table gives you the signs of the variables in every octant. So in first octant, all the variables are positive, and in seventh octant, all the variables are negative. Okay, let's discuss distance between 2 points in space. We know that how to find distance between 2 points in plane. So this is the formula for the distance between 2 points in plane. We can extend same formula in the space. So if we have 2 points P, x1, y1, z1, q, x2, y2, z2, then distance between these 2 points is given by this formula. And this can be derived by applying Pythagoras theorem twice. So if we have these 2 points, to find the distance between these two formula, we'll use these 2 points. We'll use this formula. So let's plug in the values of x2, x1, y2, y1, and z2, z1 to have distance. We have 4 minus 1 square plus 6 minus 2 square and 5 minus 2 square. 5 minus 2 square and 6 minus 3 square. And this is equal to 3 square, which is 9. 5 minus 2 is 3 square, which is 9. And 6 minus 3 is also 3 square, which is 9. And this is equal to 27 square root. And you can write it as 3 square root 3. So this is how we can find distance between 2 points in space. And this idea extends to the definition of a surface, which is called sphere. And this is similar to a circle in plane. So we define circle in plane as a set of points which are equidistant from a fixed point with coordinates x0, y0. And this fixed point is called center of the circle, and this fixed distance is called radius of the circle. So let's extend this idea to points in space. Then we have equation of sphere. So sphere is also a set of points which are equidistant from a fixed point x0, y0, z0, and this is called center of the circle, and that fixed distance is called radius of the sphere. So we can see examples of sphere in real world, like a basketball, football, a planet. So if we have center and radius of the sphere, we can find equation of this sphere by substituting these values into this equation. So equation of this sphere would be x minus 1 square plus y plus 2 square plus z minus 3 square equals to 5 square, that is 25. Similarly, if we have an equation, we can extract center and radius of the sphere. So center of this sphere would be 2, negative 1 and 4. And its radius would be square root of 36. So this is equal to 6. So if we have an equation of this form, x square plus y square plus z square plus gx plus hy plus iz plus j is equal to 0, then this equation represents a sphere or a point or has no graph. So for this, we need to convert this into this form, x minus x naught, that is, we need to complete the square, all the squares, combine x terms, combine y terms, combine z terms, and complete this square. So we'll have some constant on right hand side. If this constant k is equal to 0, the resulting surface would be a point. When we have k greater than 0, the surface would be sphere. And if k is negative, then actually this equation represents the sum of three positive numbers is a negative number, which is not possible. So there is no point on the graph for this type of equation. So if we have this equation, let's first of all complete all the squares, combine x terms, x square minus 6x. Similarly, we have y terms, y square plus 2y. And similarly, we have z terms, z square plus 4z. And 14 on right hand side will be negative 14. And in order to complete the square, divide coefficient of x by 2 and then add the square of this term. So half of 6 is 3 and we'll add 9. Now in order to keep the balance, we'll add 9 on right hand side as well. Similarly, in order to complete square of y terms, so y, take half of coefficient of y, that is 1. So we need to add 1 here, and to keep the balance, we have to add 1 here too, on right hand side too. So z square plus, so half of 4 is 2, add 4 to complete the square and add 4 on right hand side too. So we can write it as x minus 3 whole square, y plus 1 whole square, z plus 2 whole square, and right hand side becomes 0. Okay, so this is an example of this first type, that this represent only this point with the center 3, negative 1 2. So this represent the point negative 3, sorry 3, negative 1, negative 2. So this is the point uh, of this surface, this equation. And if we have this equation, then let's see what type of graph will have this equation. And for this we need to complete the squares as we did in the previous example, and in this case we don't have any y and z term with power 1, so we just need to combine x terms, x square minus 6x, and we have y square, we have z square, and this 16 is positive 16 on right hand side. And in order to make it complete it a square, we need to add square of half of the coefficient of x, and that is 9, of course, and plus 9. Okay, this gives us x minus 3 square plus y square. So you can write it as y minus 0 square. Similarly, z square can be written as z minus z square, and this is 25. And here k is greater than 0, it means this is an equation of the sphere with center 3, 0, 0 and radius 5. Similarly, you can explore third equation yourself, whether it represents first type, second type, or third type. It depends upon the value of k. So do it yourself. Okay, finally, we have cylindrical surface. Let's discuss them. Mostly students think cylinders always mean circular cylinders. Actually, in mathematics, a cylinder is generated whenever a curve moves parallel to a fixed line. So if we have an equation y is equal to x square, then it represents a curve in 2 dimension, that is in xy plane, like this. But we want to visualize this y is equal to x square in 3 space. It means for every value of z, this will produce a curve parallel to this curve, right? Like this. If we have negative value of z, curve will look like this. If we have positive value of z, curve will look like this. So the surface generated by all such curves is this. And this is called cylindrical surface. And this is parabolic cylinder because its base is parabola. Similarly, we have another equation, x square plus z square is equal to 1. And just notice the pattern. We'll discuss at the end of all the examples. And this equation is x square plus z square is equal to 1. And we need to visualize this in 3 space. So first of all, draw a circle in xz plane and then give height to the circle, or draw parallel circles to have this in y direction to have this cylinder. This is circular cylinder because its base is circle. Similarly, we have another equation, y square plus z square is equal to 1. First of all, draw a circle in yz plane and then extend it to the to x direction. So we'll have this surface, which is also a circular cylinder. Another example of circular cylinder, x square plus z square is equal to 1. This is how it looks like. Z is equal to sine y. This is also an example of cylindrical surface. So first of all, draw a curve in yz plane. So this is how it looks like, and give height to x direction. So we'll have this cylindrical surface. So you would have noticed that whenever one variable is missing from an equation, the graph extends infinitely in that variable's direction, right? So in this case, y was missing. So this actually infinitely extends in the direction, sorry, x was missing. So this infinitely extends in the direction of x. So this is common in every equation. So we can conclude that in cylindrical surface, if one variable is missing in the equation, then you can safely say that this is cylindrical surface. So that is all for today's lesson. So in next lesson, we'll continue exploring next sections of this chapter. So thank you for watching. See you in next lecture. Take care. Bye.